In the last session, we have seen the concept of the mesh analysis. Now we'll make use of the mesh analysis in order to solve the problem. So here the problem is given. Here we need to find out the mesh currents I1, I2, and I3. We need to find out by using the mesh current analysis. So by using the mesh analysis, so we need to find out the current I1, I2, and I3. We need to find out. Let us find out that one. So what we'll do is, this is the mesh current, mesh 1 and the mesh 2 and the mesh 3. So we'll apply the KVL for the mesh 1, mesh 2 and the mesh 3, and we'll simplify this one and we'll get the values for the currents I1, I2 and I3. Let us find the values now. So what we'll do is, we'll apply the KVL for the mesh 1. We'll apply the KVL for the mesh 1 here. So we'll start from the voltage source with the assumption that the current entering negative, leaving positive, it's a rise in the voltage. So it's a 100 minus the drop across this one is, so it's a 6 ohm resistance is there. So minus 6 into, so it's I1, and the drop across the 4 ohm resistance is, the two currents are flowing. The two currents are flowing in the 4 ohm resistor. One is I1 and other I2. So minus 4 into, so it is I1 minus I2 is equal to the 0. Now we'll simplify this expression and we'll send the known quantities towards the RHS part, and unknown quantities will retain here. So minus 6 and minus 4 are in the same polarity, so that will become equal to the 10 I1 will get minus 4 I2. So this will become equal to the 100 volts will get. Let us call this as the equation number 1 here. So this is the equation 1 we got here. We're applying the KVL for the mesh 1. So similarly, we'll apply the KVL for the mesh 2. So apply KVL for the mesh 2. We'll apply the KVL for the mesh 2 here now. So what we'll do is, we'll start from the resistance R. So minus 2 into I2 minus the drop across the 4 is, the two currents are flowing. One is I2, other one is I3. So it is minus 4 into, so it is I2 minus I3 minus the 4 ohms. Again, the two currents are flowing. One is I2 and I1. So it is minus 4 into, so it's I2 minus I1 is equal to the 0. Now let us simplify this one. Let us simplify this one here. So in order to simplify this one, we'll take the I1 current. So it is minus 4 into I1 will get. And in the mesh 2, we have the 4 plus 2 plus 4. So it is plus 10 into I2 will get minus, with the mesh 3, the common between mesh 2 and mesh 3 is 4 ohm. So minus 4 into I3 is equal to 0. Call this as equation number 2 here. Call this as equation number 2. Now we'll apply the KVL for the mesh 3. We'll apply the KVL. So apply KVL for mesh 3. We'll apply the KVL. So this is a mesh 3. We'll apply the KVL. We can from the voltage source with the assumption that if the current is entering positive, leaving negative, it's a drop in the voltage. We need to consider with the minus sign we need to consider. So it is minus 50. And drop across the 8 ohm resistor is, so minus 8 into I3. And the drop across the 4 ohm resistor is, so it's minus 4 into, so it is I3 minus I2. And the drop across the 6 ohm resistor is, so minus 6 into I3 is equal to the 0. Now let us simplify this one. So if you are going to simplify, so minus 50. So since it's our opposite polarity, and since there is no I1 terms, so it is 0, and I2 terms, so it is minus 4 into I2. We have the two resistance are there. So 6 plus 4 plus 8. So it is 18 I3. So this is equal to the minus 50 volts will get. So call this as the equation number 3 here. So we got the equation 1, equation 2 we got here, and as well as the equation 3 we got here. Now let us represent all those things in the matrix format so that we can have the the values you're going to get in the matrix format in the detail we'll get here. So we'll represent in the matrix format and we'll evaluate this one. So in the matrix format, so it is 10 minus 4, and in the equation 1 the I3 term is not there. Let us make it as 0. So it is minus 4 and the 10 and it is minus 4, and for the loop 3 we don't have a I1 current, so it is minus 4, that is from the I2 current we have, and it is 18 we can represent in terms of the other column matrix where the current I1, the current I2 and the current I3 we can represent. So equal to the remaining part, so that is the voltage 100, 0 and the minus 50. So we got here. Now to solve this one, we can apply the concept of the Cramer's rule. We can apply, or else we can go for solving in the calculator. We can go here by representing in terms of the equation. Let us take the calculator. In that one, you can select the mode. You can select and select the equation. And once you select the equations, it is going to ask for the unknowns. It is going to ask here. So you can represent 2 or 3. We can represent as a 3 unknowns. We can represent, and it is going to ask the value for the A1. So we can represent 10. And the value for the it is B1 is minus 4, and the value for the C1 is 0. You can represent, and the value for the voltage, it's 100 volts. And similarly for the second row you can enter, so it's a minus 4, and next one is it's a 10, and next one is minus 4, and the value for the other is 0. And next for the third row, it's I1 coefficient is 0. Next one is it is minus 4, the I2 coefficient, and I3 coefficient is 18. So you can do represent. So, and D3 is it's a minus 50 if you represent. So we get the value for the mesh current 1 we got here. So the mesh current 1 is nothing but it is equal to the I1. So it will be equal to the 11.53 amperes we get. And similarly for the I2, if we type equals, so it is equal to the 3.84 amps will get. And similarly for the I3, if we type I3 equals, so it will become equal to the 1.92 amps will get. So this like this we can obtain the values in the calculator, we can obtain easily. So for the Cramer's rule, we need to go for the Cramer's rule, where when there is a it is not possible to solve by using the calculator, we can go for the Cramer's rule, where the AC part of the network will be there. So there we can make use of the Cramer's rule and we can evaluate this one. So this is how we can use the concept of the mesh analysis in order to solve this problem. In the next section, we'll see some more problems on the mesh current analysis we'll see here, and we'll do evaluate the problem. We'll do